Hey everyone, welcome back for another deep dive. We're going to be tackling some seriously big questions today, the kind that keep you wondering about, well, the universe and everything in it.
Exactly. And the best part is, you don't need a degree in astrophysics to get this.
So buckle up, because we're diving headfirst into the mind-blowing worlds of black holes and quantum mechanics, ready to have your mind blown.
Me too. First up, those cosmic monsters we call black holes, where gravity is so strong that not even light can escape. I always thought it was pure sci-fi, but then, boom, 2019, scientists actually snag a picture of one.
Yeah, that was huge. I mean, we can't actually see a black hole directly. They don't exactly emit light. It's
Yeah.
all about the effects they have on everything around them.
Right, right.
That blurry ring of light, the one from the Event Horizon Telescope, that's the black hole's event horizon. Think of it like the point of no return, lit up by all that superheated gas just swirling around it.
So, like, if you picture water going down a drain, but swap the water for, like, actual light being twisted and pulled by the black hole's gravity. Am I getting that right?
That's a really good way to visualize it, actually. What's even crazier is that this picture basically proves what Einstein predicted over 100 years ago with his whole theory of general relativity.
Wow.
Right. He said that when massive stars finally die and collapse, they could, like, warp the fabric of space-time, creating these gravitational sinkholes. And that's what we call black holes.
Okay, that's mind-blowing. It really makes you realize how much we don't know about the universe. But if black holes can warp space-time, what happens to, like, everything else? Is it all just doomed to fall into one of these things eventually?
Well, that's a question that keeps a lot of cosmologists up at night. Studying black holes is kind of like studying the universe's expansion, dark matter, all these huge mysteries. Every time we get an answer, it feels like 10 more questions pop up.
And that's what makes it so fascinating, right?
Ex-
Okay, so from the incredibly massive to the incredibly tiny, let's jump to the world of quantum mechanics. It's like stepping into some weird funhouse where the rules of reality go out the window.
Tell me about it. The quantum realm. Think subatomic particles. Things get truly strange down there. We're talking particles acting like waves, existing in multiple states at once.
Yeah.
It's enough to make your head spin.
Yeah, it definitely bends the brain a little,
Yeah,
but it's also where some of the most exciting discoveries are happening, isn't it?
absolutely.
You always hear about the double slit experiment. I've got to admit, even after reading about it a bunch, I'm still not sure I completely get it.
It's one of those things that really shook up physics. Imagine you shine a light at a wall, but the wall has two slits in it. What would you expect to see on the other side?
Two lines of light. Right.
Exactly. But when you use tiny particles like electrons, instead of just a beam of light, something strange happens. Instead of two bands of light, you get this interference pattern, as if the electrons are going through both slits at the same time, kind of like a wave would.
Hold on, you're saying these tiny particles are in two places at once?
In a way, yeah. It's like they're in this um, superposition of states. Think of it like a cloud of possibilities until we actually try to measure where they are. And get this, the act of observing them seems to change the outcome.
That's the observer effect, right? When I first heard about that, my mind was totally blown. It's like these particles know we're watching and decide to act differently because of it.
Yeah, it's one of the biggest mysteries in quantum mechanics. How can just looking at something, measuring it, actually affect it? It suggests this wild connection between our consciousness and, like, the basic fabric of reality.
I don't know about you, but I'm still trying to wrap my head around that one. It's a lot to process, and it gets even weirder, right?
You're thinking about entanglement, where two particles, even if they're separated by, like, the entire galaxy, are still connected. Whatever happens to one instantly affects the other.
Exactly. It's like they have this secret communication system that ignores all the laws of physics. It's like they're sending telepathic messages across the universe or something. But how does that even work? If they're connected instantly, doesn't that mean something's traveling faster than light?
That's the thing about entanglement. It kind of throws everything we thought we knew out the window. It's just this connection that goes beyond distance, like those two particles are still part of the same, I don't know, system.
Like two sides of the same coin, even if you flipped one side on Earth and the other ended up like light years away, and all this weirdness is happening at the smallest level. What other strange stuff is hiding down there in the quantum realm, just waiting to be discovered?
It's a whole other world down there, that's for sure. But speaking of mysteries, there's another one that hits a little closer to home. The human brain.
Oh, good point. We've been talking about the mysteries of the universe, but what about the mysteries right inside our own heads? This 3-pound organ that somehow handles thought, emotion, creativity, all of it. And we're still just scratching the surface of how it works. It's like the most complex thing in the known universe. Kind of makes you feel pretty small.
It really does. Billions of neurons,
Uh-huh.
each connected to thousands of others, sending these electrical signals. And somehow, that creates everything we experience.
I
The
see.
chocolate, the feeling of love, the memory of, like, your first bike ride.
And all those experiences, all those memories, they're all stored in these, networks of neurons. It's like our brains are carrying around this massive library of our lives, and it has different sections for different types of memories, right? Short term, long term. And sometimes you can just pull up a memory instantly, even if it happened years ago. It's incredible.
And it's not random either. Recalling a memory, it's a whole process. Different parts of the brain working together. Like the hippocampus, that's a part of your brain shaped like a seahorse. It's super important for making new memories. But even those random memories that pop up out of nowhere, like from your childhood, those might be triggered by something you smell or see. It shows how connected our senses are to our memory.
That reminds me of this one time. Actually, you know what? Never mind. Probably not that interesting. But it's funny how a familiar smell can just take you right back to a specific moment. It's like our brains are way more powerful than we realize.
Definitely. And what's even more amazing is how adaptable our brains are. It's not like they're set in stone. They actually change and rewire themselves throughout our lives.
So they're constantly learning and adapting.
Exactly. It's called neuroplasticity. Basically, our brains can form new connections, make existing ones stronger, even reorganize whole sections based on new experiences, what we learn, even if we get injured.
So every experience we have, every book we read, it's literally changing the physical structure of our brains. It's kind of empowering, but also, wow, a lot of responsibility.
It definitely challenges that whole idea of a fixed intelligence. But this flexibility, it also means we're vulnerable. Our brains are shaped by our experiences, good and bad, and those experiences leave their mark.
It's a good reminder to pay attention to what we expose ourselves to, the information we consume, because it's literally shaping our brains. This deep dive is already making me want to meditate more, go for a run, maybe log off Twitter for a bit.
It's all about finding that balance. But while we're on the topic of the brain and all its mysteries, we can't forget about dreams.
Dreams, right? Those nightly adventures into the strange and sometimes nonsensical parts of our minds. So, what's the deal with dreams? Are they just random, like some scientists say, or is there something more to them?
That's the million-dollar question, isn't it? People have been debating that for centuries.
I know I have some dreams that are so vivid, so weird. It feels like there's got to be some deeper meaning. Then again, sometimes I dream about being chased by a giant talking banana, so I don't know, maybe it's just randomness.
That's the thing about dreams, right? They can be
Uh-huh.
super profound one night and then totally ridiculous the next.
Right.
Some people think dreams are how we process emotions
Mhm.
or sort through memories, maybe even like a safe space for our brains to rehearse for threats. Others say, nope, it's just the brain making sense of random activity while we sleep.
So our brains are basically making their own entertainment with mixed results sometimes.
Yeah, something like that. Maybe those weird dreams are just our neurons getting a little too creative on their break.
Yeah.
But it just goes to show, even when we sleep, our brains are still going.
Always on. Speaking of always on, there's another area of science we should talk about, something that's really pushing the limits of what's possible. CRISPR technology.
Yeah, CRISPR. Now, this is one that always blows my mind. We're talking about editing the code of life itself. It's both exhilarating and, honestly, a little bit scary, don't you think?
It's definitely a game changer. CRISPR basically gives us the ability to make super precise changes to DNA, kind of like using a word processor to edit text.
Wow.
Imagine fixing genetic defects, curing hereditary diseases, maybe even enhancing certain traits. The possibilities are, well, pretty much endless.
It's like having a set of molecular tools to rewrite the blueprints of life itself. I know one of the most promising areas is treating genetic diseases.
Right, things like cystic fibrosis, Huntington's disease.
Exactly. But CRISPR could also change agriculture, create new biofuels, even help us fight climate change. It's hard to overstate the impact it could have.
You're right, the applications are huge. And while the potential benefits are amazing, we also have to talk about the ethics of it all.
Right. It's like we're stepping into uncharted territory here. We can't just ask what we can do with this technology, but what we should do.
100%. This is a conversation that goes way beyond scientists. We need ethicists, policymakers, and honestly, everyone needs to be involved. What happens when we start altering the human germline? How do we make sure everyone has access to these technologies? These are questions we need to be asking right
It's a
now.
lot to think about, but that's what's so incredible about science, isn't it? It forces us to really examine the universe, our place in it, and the implications of what we discover.
It's a journey that never really ends. From those mind-boggling black holes to the mysteries of our own brains, to things like gene editing that could change everything, science keeps on amazing us.
And reminding us how much more there is to learn. So to everyone listening, if this deep dive sparked your curiosity, keep exploring. Read a book, watch a documentary, talk to someone about these topics. The more we learn, the more we see how connected everything truly is.
From the vastness of space to the inner workings of our own minds, the pursuit of knowledge is a journey worth taking. Who knows what amazing breakthroughs are just around the corner? So keep asking those big questions and never stop exploring the wonders of science.